Welcome to the Deep Dive. Today we are strapping in for a really interesting one. We're looking at Vortex.
Right.
It's this piece of software that, well, it seems to be bridging complex physics and advanced audio processing.
Yeah.
Our mission today is to unpack what our sources are calling the world's first audio effects processor using real-time fluid dynamics simulation. Sounds ambitious.
It does sound a bit like science fiction, doesn't it? But it's actually real and functional. Vortex is, I think, genuinely revolutionary because it's not just, manipulating a waveform. It treats sound like a force that actually moves a simulated digital fluid. It combines really solid web audio API processing with this real-time fluid dynamics thing.
Optimized for audio-visual experiences, they say.
Exactly. Specifically for creative, highly responsive AV stuff.
Okay, hold on. Let's quickly nail down that platform bit.
Right.
Web audio API processing. Why is that critical? Sounds quite technical for maybe some
And
listeners.
it's absolutely critical because it means Vortex runs entirely in your web browser. Yeah, natively. So accessibility is huge. You don't need special dedicated software. You get these like professional grade tools right there in Chrome, for instance.
Right.
It really sort of democratizes this high level processing.
That's a definite game changer for creators. And this accessibility is paired with this really intriguing core concept organic, living sound. The sources talk about an audio fluid feedback loop.
Yes, that feedback loop is absolutely the heart of Vortex. The sound input your voice, maybe a drum loop, whatever you feed it, it actively drives the fluid simulation.
Right.
It literally creates currents, splashes, flows in this virtual liquid. And then that movement, that dynamic kind of chaotic motion, it feeds back. It modulates the parameters of the audio effects themselves. Things like delay time or maybe filter depth.
So if I clap my hands loudly, the virtual water splashes, right? And that momentary splash could suddenly change, say, my reverb intensity. It's like a constant back and forth.
Exactly that,
Yeah.
a bidirectional dance. The key insight, I think, is that the effects become inherently unpredictable. And crucially, they're non-repeatable in the way, standard effects are. You get this amazing blend of technical control and, well, natural chaos. The sound really does seem to breathe with the visuals.
Okay, I appreciate the chaos, the organic side, but I also see Vortex is built on a pretty serious foundation. Before the liquid starts swirling around, this thing is a professional audio tool, isn't it?
Oh, absolutely. The architecture is definitely professional grade. We're talking a comprehensive 10 effect chain.
10 effects?
Yeah, running from source to master. You start with filters, then distortion, a 5-band EQ, auto walk. Then you hit that classic modulation group, delay, vibrato, flancher, chorus, reverb. It all finishes with dynamics processing.
That's a full production signal path right there. But I did notice they seem to have put a lot of effort into the distortion section specifically. Why a 3-channel distortion system, clean, overdrive, solid state, isn't one great distortion usually enough?
Well, I think it's about having surgical control over your bass tone before the liquid gets involved.
Ah, okay. Preparation.
Right. Having those 3 channels lets you shape everything from just subtle harmonic warmth, maybe using the clean channel as a sort of parallel blend, all the way to really aggressive clipped sounds with the solid state channel.
I see.
That flexibility means you can dial in really specific core tones, and that then dictates how dramatically the fluid is going to modulate the texture later on. It's about building a robust starting point for the dynamic stuff.
And speaking of robust, the dynamics section seems key too. Why put professional grade dynamics after all the distortion and modulation? Isn't that usually earlier?
Well, that placement is pretty essential here. It acts as the safety net, really.
Safety net.
Yeah, because once you start throwing chaotic fluid dynamics at things like delay, feedback, or distortion gain, you can create these massive transient peaks that could just instantly clip and, well, ruin your audio.
Right, yeah.
So the dynamic section, sitting post-distortion, ensures containment.
Can you give us some of the specifics there? I see numbers like ratios, dB points mentioned. What does that mean for someone using it?
Sure. It includes a full compressor, right, designed to squash those loud peaks and level things out. You get proper control over the ratio, how severe the compression is. So you could dial in, say, a moderate 4.0.1 ratio for fairly aggressive leveling, or something gentler.
Okay.
And the threshold where compression kicks in can go down to NATX 24 dB. That's, a moderate setting designed to keep a good chunk of the signal under control.
So you could have gentle compression normally, but then if the fluid dynamics suddenly make the delay feedback spike like crazy, the compressor just clamps down hard automatically, protects the output.
Precisely. And the very last step is the limiter, which is crucial. It acts like a hard ceiling, typically set around megach 1.0 dB max output. It makes sure that no matter how wild the fluid makes the signal, you never get that nasty digital clipping or unwanted distortion right at the final output. It's like the firewall that guarantees professional quality.
Okay, that makes sense. Now let's talk about getting audio in. The input flexibility seems like a big deal, especially for content creators maybe. It's more than just uploading a file, right?
Oh yeah, the browser audio capture feature is, well, it's a massive creative component. You can capture and process the audio from basically any other open tab in your browser.
Any tab, like YouTube, Spotify.
Yep, YouTube, Spotify, Bandcamp, anything playing audio in another tab.
Yeah.
This lets you do real-time sound design on existing stuff. Fantastic for, say, remixes or generating unique soundscapes for video content you find online.
But there's a catch, isn't there? A crucial step you have to follow.
Yes, absolutely. If you ignore this, it's a mess. Yeah. You must mute the source tab.
Mute the YouTube window itself, for example.
Exactly. Mute the source tab or wear headphones and make sure you're only listening to the Vortex output. If you hear both the original and the processed sound, you'll get phasing, doubling. It just sounds bad.
Got it. Mute the source, hear only the processed living sound.
That's the key.
Okay, so that's the solid technical foundation. Now, let's get to the really unique part. The immersion control. This is the main dial, isn't it? The secret sauce.
It really is the master blend control for the chaos, yeah. The immersion control basically determines how much influence the fluid dynamics have over the audio parameters.
So if I turn it all the way down to 0...
then you just have a very nice standard 10-effect processor. Yeah. The effects are static, predictable, what you'd expect.
Right.
But as you crank it up towards 100%, the sound becomes, as they say, fully modulated by the fluid simulation. This is where you shift from predictable effects to these truly dynamic organic soundscapes that are just constantly moving and evolving. It's the control that really blends that traditional audio engineering with, generative art almost.
Let's trace that loop again, focusing on the first part, audio influencing the fluid. What specific controls let the music or sound input actually push the digital water around?
Okay, there are several quite precise controls here. You've got splash, which sets the overall sensitivity, how much the audio affects the fluid, to give a range, 0.15 to 0.75. Then there's flow. That defines the base level of chaos versus stability. If flow is at 0, the liquid just sits there, completely static, even if the music is blasting.
But it gets more specific than just general splashing, right? The audio can actually influence the direction of the flow.
It absolutely can. There's a control called bias. This acts like a sort of virtual magnetic field, pulling the fluid in a specific direction. You can set the angle 270 degrees means it pulls straight down.
Interesting.
And what's really fascinating here is that the activation of bias, and also another feature called the attractor, they're tied to specific audio level ranges. Say, only when the input hits between -20 and -5 dB.
Wait, so the sound has to reach a certain loudness threshold to trigger this directional pull?
Exactly. So imagine you have a podcast track, mostly quiet speech. Then suddenly the speaker shouts, or there's a loud sound effect. That peak could instantly trigger the bias, forcing the fluid to dramatically shift direction just for that moment.
Wow, okay, that's very dynamic.
It is. And the attractor feature pushes this even further. It defines a specific point on the screen that either attracts fluid particles or repels them. Positive values attract, negative repel. You can even control the size of its influence, maybe a 400 pixel radius or something.
So a sudden loud drum hit could trigger an attractor point, causing the fluid to instantly swirl inwards towards that point, like a vortex opening up.
Spot on. And crucially, that instantaneous visual change, the fluid swirling, simultaneously causes a change in the audio effect it's linked to. Maybe your flanger depth suddenly collapses inwards too, mirroring the visual.
Okay, now let's flip it. The fluid is moving chaotically, dynamically, being pushed around by the audio. How does it talk back to the audio effects chain? How does the system measure the moving liquid and turn that back into usable control data?
Right, you need to monitor the fluid state in real time. The system uses specific metrics, parameters like Vort norm and fluid strength. Vort norm, for example, is basically measuring the swirling energy, the vorticity of the flow.
Okay.
This stream of dynamic data, constantly changing based on the fluid's movement, is then popped directly back to modulate parameters within that 10 effect audio chain we talked about earlier.
Give us some concrete examples. This is where the living sound idea really comes to life, I guess. How does that digital swirl actually translate into sound that feels organic?
Well, you see that dynamic data applied pretty broadly across the effects. For instance, the fluid movement can directly influence the delay time and feedback settings,
Meaning,
meaning your echo's timing and how long it repeats for are constantly speeding up, slowing down, shifting based on how the fluid is flowing visually. You can imagine the echo becoming shorter and tighter as the fluid calms down, maybe.
or maybe a sudden burst of fluid movement causes the delay feedback to spike into self oscillation for just a moment before settling back down. That's real texture.
Exactly. That's the kind of organic behavior you get. It also applies to vibrato rate, the speed of the pitch wobble, and its depth, the intensity. The fluid flow influences reverb decay time and pre-delay as well.
So the reverb tail length changes on the fly?
Yeah, how long the reverb lasts and when it even starts relative to the dry sound. Even the Ottawa LFO depth can be modulated by the fluid. So the filter sweep isn't just a predictable cycle. Its intensity is dictated by the liquid's movement.
Right.
The result is modulation that feels, well, natural, almost like it's breathing instead of being locked to a perfectly timed static.